Okay. This is Enzo, thank you. This is water, okay? It's approximately 109, 105 degrees that separate the bonds. There's a bond angle there, correct? And that's water. This is hydrogen and oxygen, okay? Now, when they come near each other, remember, the oxygen is partially negative or positive? The oxygen is partially negative, so it's going to orientate like that. Not like this, but it's going to be like that. Correct? You get that? You get that? Can you see it now? Okay. So they're going to orientate away from each other, so that you're going to form what literally looks like diamond. You know, they call, if you have pure, yes.
It's kind of dark on the screen. You might be difficult to see.
Dark on the screen? Yeah, the screen is not that bright. Let's see.
It's kind of
Yeah, the lighting here is not great, believe it or not.
like hard to see.
Okay, you gotta take what you can get. Okay, so here I have a bigger example of the molecule. So I have hydrogen there and hydrogen there. And what happens is this. Each individual molecule, it's going to look like this. You see this? This is, everything is 109, 105, etc. It looks like diamond, okay? Where this is that is a pair of electrons, correct? Mm-hmm. Yes? That's going to be a hydrogen. So there are two bonds here, two covalent bonds, and then two unused, unpaired electrons. So what happens is this. The molecules from the other water molecules line up. They literally line up. And they're going to form what's going to be a tetrahedral kind of substance. Okay? So now these are going to line up like this. See? Where do you see that I have two physical bonds and two chemical bonds, two covalent bonds right there. And then this is a non-bonded pair where you're going to have an attraction. It's not going to be really a bond. So you're going to form it with the hydrogen, the partially positive hydrogen, and the partially negative oxygen, and they're going to form like this. So do you see that? You see that? So in actuality, you're going to have this kind of like tetrahedral structure. And do you see that there's going to be a lot of space in there because everything's going to line up? So you're literally going to have a lot of places to hide. See? In the what? In the ice. So ice is going to expand when it hardens because it's going to line up in this tetrahedral structure. It's going to line up in this tetrahedral structure like literally like diamonds, and it will expand. And how many people have ever seen ice gardens where they do ice sculpting? With chainsaws, yeah. You ever see that?
Yeah.
It's utterly beautiful, especially when you have this artificial light. For instance, it's usually done at night so it doesn't melt during the day. And you have these lights in the park that are shining on the ice sculpture. And it literally looks like diamonds, solid diamonds, the way the ice is reflecting and refracting off the ice and through the ice. Yes? It sparkles like diamonds because the water becomes less dense in the solid state because of this. I like to call. I don't like the way the book represents it because it represents it. The book represents it like some kind of two-dimensional hexagonal ring, polygonal, right? Six-sided hexagon, where it's actually like this, where you have two chemical bonds that will line up with the unbonded pair of electrons from the water molecule. Okay, so let's make that. So things are going to kind of look like this. Okay, so you have two chemical bonds, two unbonded pairs that will form physical bonds that can be broken without changing the nature of the water. Okay, and they're going to line up like this. So you're going to get this lineup of charges that will literally create a molecule that has a tetrahedral shape. Remember we did crystals? And it was that one crystal, how that lined up gave the crystal its nature. Remember that? Well, the same idea is true with water. Water can form a crystal with itself. You simply call it, what's the name of the crystal that water forms with itself?
Ice.
Ice. The ice crystal. Okay? So what was this one? This was going to be hydrogen bonding. No, it's going to be what? Water, solid water part 2. Okay, we're off.